Okay kelas, kita akan proceed dengan second hour tutorial Okay, so second hour ni dia melibatkan Nernst equation Okay, which we use to calculate E cell lah, standard cell potential for any concentration Okay, so question number 1 here. So dia bagi the standard electrode potential are given below lah untuk nickel dengan SN tu tin Okay, untuk nickel dengan tin. Okay, so the E0 value for nickel is minus 0.25 and for tin is minus 0.136 volt. Okay, so first dia suruh write an equation for the spontaneous reaction. So again the same thing, before we proceed we must first identify siapa kita punya anode dan cathode, siapa yang akan undergo oxidation or reduction lah. Okay, so the one which has a more negative E0 is our nickel Okay, so this one is our anode lah. E0 value yang lebih negatif adalah kita punya anode dan dia akan undergo oxidation. Okay, alright, dan ini adalah kita punya cathode dan dia akan undergo reduction. Okay, so walaupun equation dua-dua tu diberi dalam bentuk reduction, nanti untuk anode tu kita kena reverse the equation lah. Okay, supaya dia jadi oxidation. Okay, dan bila kita reverse equation, kena ingat value E0 tu kita tak perlu reverse lah, maksudnya kita tak perlu change the sign Okay, alright, so now what we do the first part first. Okay, so anode oxidation so apa yang berlaku, okay, kita punya nickel tu okay akan oxidize jadi nickel ion Ni2+. Okay, and for our cathode it's the same lah, sebab tin ion tu Sn2+ will undergo reduction to give us tin. Okay, so before we write the overall equation tu, we must make sure that our electrons are balanced lah for both anode and cathode So kalau you tengok on opposite side ni, so the number is balanced lah, 2 electrons and 2 electrons. Okay, so we don't have to do anything lah. Okay, so what we do next, we just add up the half equations tu. Yang dekat sebelah kiri, kita tulis dekat sebelah kiri our reactants and the ones on the right, we write on the right hand side lah. Okay, so this is our overall equation. Okay, next okay, for B is to write the cell notation. Okay, so cell notation kena ingat kita mula daripada sebelah anode dulu. Okay, dan ni sekarang kita punya solid adalah nickel lah, that means kita pakai active electrode Okay, alright, so we write first our electrode nickel. Okay, and then kita punya solution Okay, ada phase boundary tu single vertical line. Okay, Ni plus aqueous one molar. Okay, and then we have our salt bridge. Dekat sebelah cathode, ion tu akan undergo reduction lah. Okay, our dekat cathode kita punya tin ion Okay, tin ion tu okay, aqueous 1 molar will undergo reduction okay, to give us tin solid. Okay, alright, okay, so make sure you should be able to write overall equation dan juga cell notation lah okay, for the half equations tu. Okay, next tu disuruh kita calculate E0 cell lah. Okay, the standard cell potential. Okay, so again benda yang sama lah, E0 cell is equals to E0 untuk cathode minus E0 untuk anode. Okay, so what we need to do, okay, cathode dia punya value adalah okay, negative 0.136 volt minus untuk anode negative 0.250 volt. Okay, so the answer that you should get is positive 0.114 volt. Okay, alright. So ni adalah inert cell. Okay class, now let's have a look at question D. They ask us to calculate the E cell at 25 degrees Celsius if the concentration of nickel ion is 0.01 molar and concentration of tin ion is 1 molar lah. Okay, bila dia suruh calculate E cell tu, you kena tahu kita kena pakai Nernst equation lah. Okay, so we write the formula first. Okay, E cell is equals to E naught cell minus 0.0592 over N. Okay, log concentration of ion in our product, which is Ni2 plus lah. Okay, over concentration of ion in our reactant, which is tin ion Sn2 plus. Okay, so E naught cell kita dah kira dekat bahagian C tadi. Okay, and number of electron, bila kita buat overall equation, kita dah tentukan kita punya bilangan elektron tu sama dengan 2 lah. Okay, so we just substitute the values lah. Okay, so E cell tu tadi kita dapat 0.114 volt minus 0.0592 over 2 log concentration of nickel ion is 0.01 molar. Okay, and concentration of tin ion tu is 1.0 molar. Okay, so substituting all these values should give you positive 0.173 volt. Okay, alright. Okay, so the last question tu okay, so they ask us, okay, what could be done, okay, to obtain a higher E cell value. Okay, higher E cell value than that of D. Okay, so kalau kita tengok balik kita punya Nernst equation ni, okay, this is our Nernst equation ni. Okay, what can we do to increase the E cell value as compared to D lah. Maksudnya kita nak nilai yang lebih besar lah. Okay, so what we can do, okay, kita nak pastikan portion sebelah sini value dia lebih kurang lah, so that when E naught cell minus that thing, you will get a smaller value. Okay, so what are the things that you can suggest? First is you increase the concentration of the reactant ni, kita punya Sn2 plus ni. Okay, so you increase the concentration lah. Okay, increase the concentration of reactant, which is our tin ion Sn2 plus. Or we can do the opposite, which means we reduce the concentration of our nickel ion. Okay, decrease or reduce lah the concentration of ion in our product. Okay, alright. And what we can do, we can also increase the E naught cell tu. Okay, we can increase this portion here lah, supaya nanti E naught cell tolak dengan bahagian ni, we get a bigger value. Okay, so how we can increase the E naught cell tu? For example, kalau untuk anode tu kita boleh pakai half cell yang ada E naught cell yang lebih negatif, ataupun untuk cathode kita boleh pakai half cell yang ada E naught yang lebih positif lah. Okay, so that we can get a bigger value for our E naught cell tu. Okay, so the third one tu will be increasing the E naught cell value lah, by using different half cell. Maksudnya kita change kita punya half cell tu. Sama ada kita boleh pilih untuk anode, kita pilih half cell yang ada E naught yang lebih negatif lah. Half cell with more negative reduction potential. Maksudnya E naught value tu reduction potential for anode. Or untuk cathode kita boleh pilih half cell yang ada E naught value lebih positif. With more positive reduction potential for cathode. Okay, and another thing kalau you nanti refer balik to the lecture note tengok balik formula asal. Okay, tengok balik formula asal Nernst equation sebelum kita simplify ni. Okay, alright, so dia ada expression untuk temperature pun lah. Okay, so to get a higher E cell value, okay, another thing which we can do is to lower the temperature. Okay, lowering the temperature. Okay, so if you see here, okay, there are few ways which we can do lah to increase the E cell value tu. Make sure you clear lah siapa kita punya ion product, reactant, okay, and then macam mana nak besarkan value E naught cell tu. Kita change the half cell supaya kita punya value tu lebih besar. Okay, alright. Okay, so this is another question whereby kita akan still apply the use of Nernst equation. Okay, so it says here an experiment is carried out to determine the pH of an unknown solution using a galvanic cell consisting of copper and hydrogen electrodes. Okay, so the pressure of hydrogen gas is 1 atm and the copper electrode tu is immersed in 1 molar copper 2 ion Cu2 plus solution, and E cell measured at 25 degrees Celsius is positive 0.48 volt. Okay, alright. So first they ask us to write a balanced equation for the cell reaction. Okay, so before we write the balanced equation tu, you kena tahulah siapa yang akan undergo oxidation, siapa yang akan undergo reduction. Okay, so involving hydrogen gas and hydrogen electrode ni, you must know this is our standard hydrogen electrode lah, kita punya SHE. Okay, dia punya value tu adalah 0 volt. Okay, and for copper, okay, for copper ion and copper electrode tu, dia punya E naught value is positive 0.34. Okay, so you kena tahulah kita punya hydrogen ni is our anode and our copper ni is our cathode. Okay, so you must be able to identify that one first, baru kita boleh proceed. Okay, so what happens at anode? Hydrogen gas will be oxidized lah to give us hydrogen ion. Okay, so again balancekan bilangan dulu, ada 2 here, alright, and then sebelah kiri charge dia kosong, sebelah kanan positive 1 ada 2, so positive 2, so we add 2 electrons on the right. Okay, dan untuk cathode pula akan berlaku reduction lah. Okay, so ion tu akan terima elektron. Apa ion? Copper tu ion tu will receive electron to give us copper solid. Okay, alright, so since untuk anode dengan cathode, okay, both involves 2 electron, so kita tak perlu nak buat apa-apa lah, tak perlu darab apa-apa, so we just add up lah and get our overall equation tu. Okay, so this is the overall equation that you should get lah. Okay, so the next part tu dia suruh kita kira pH okay, dia suruh kita kira pH of the unknown solution tu. Okay, so how do we do this? Okay, so before we proceed to find the pH of the solution tu unknown solution tu, kita kena kira dulu concentration of hydrogen ion. Okay, so macam mana kita nak kira concentration of hydrogen ion with all the values and information given? So kita kena pakai kita punya Nernst equation lah, whereby E cell is equals to E naught cell minus 0.0592 over n, okay, log, okay, concentration of ion in our product. Okay, so kalau you perasan okay, depan H plus kita ada 2 mol. Okay, so dia akan jadi kuasa 2. Okay, alright. And our reactant okay, reactant kita ada copper to ion, concentration of copper to ion. Okay, and another thing that you should take note here is that okay, kita perlu ambil kira juga, okay, kita perlu ambil kira juga kita punya gas state ni, okay, our hydrogen ni. Okay, so the partial pressure of hydrogen tu kita kena ambil kira sekali lah. Sebab bila kita buat expression ni, okay, product over reactant ni kita kena ambil kira bukan sahaja dalam aqueous tetapi dalam gaseous state jugalah. Okay, alright, so you must also include the partial pressure of hydrogen. Okay, so itu yang the tricky part here ni. Okay, so you must know to include the partial pressure of hydrogen gas lah. Okay, so actually value dia 1 atm, so it won't affect our final value lah, but still in our expression tu you kena tulis. Okay, so next what we do, okay, so E cell is given as positive 0.48. Okay, E naught cell ni kita kena kira. Okay, so let me just do down here lah okay, so E naught cell adalah E naught cathode, which is our copper, minus E naught anode, which is our hydrogen lah, SHE Okay, so cathode kita copper, the value is positive 0.34 volt, and anode tu for SHE the value is 0 volt. Okay, so your E naught cell tu is positive 0.34 volt lah. Okay, minus okay 0.0592 over n, dia punya value adalah 2 okay, log, okay, concentration of H plus yang kita nak cari. Okay, concentration of copper ion is given as 1 molar lah. Okay, and partial pressure of hydrogen gas tu or pressure of hydrogen gas tu is 1 atm. Okay, so this one is maths lah, so you kena rearrange all. Okay, and then you should get the concentration of hydrogen ion as 4.1365 times 10 to the power of 3, 10 to the power of negative 3 negative 3 per molar. Okay, so ini adalah value for the concentration of hydrogen ion kita. Dah ada tu baru kita boleh kira pH. Okay, pH is negative log concentration of hydrogen ion. Okay, so you just substitute the value ni, concentration of hydrogen ion ni ke dalam ni. Okay, the pH that you should get is 2.36. Okay, alright. Okay class, we will continue with face-to-face question second hour. Okay, so they ask us to calculate the equilibrium constant K, okay, for the following reaction using standard reduction potential at 25 degrees Celsius. Okay. So first thing you kena faham bila melibatkan soalan ni yang di mana disuruh kita kira equilibrium constant K ni, okay, kita kena pakai kita punya Nernst equation. Okay, kita kena pakai kita punya Nernst equation lah. Alright. So actually ada beberapa kriteria yang you perlu tahulah bila nak kira K ni. Okay, bila nak kira K maksudnya kita nak kira the constant at equilibrium. Okay, so ada dua benda yang you kena tahu. Okay, dalam Nernst equation tu. Okay, so at equilibrium kita punya E0 cell tu, kita punya E cell sama dengan, bukan E0 cell kita punya E cell tu, cell potential tu sama dengan 0. Okay, and kita punya Q tu, yang product over reactant tu, ion atau gas tu, kita samakan dia dengan K. Okay, so what we do next is we write our expression tu lah. Okay, E cell is equals to E0 cell minus 0.0592 over N. Okay, log concentration of ion in the product is our magnesium lah. Okay, over concentration of ion in our reactant, which is zinc ion. Okay, so yang ni concentration of magnesium over concentration of zinc ni kita just samakan dia dengan K saja. Okay, dan you tahulah E cell tu sama dengan Z 0. Okay, E cell at equilibrium is equals to 0. Okay, so apa buat rearrange balik the equation tu. Okay, so E0 cell sama dengan 0.0592 over N log K. So you should be able to reach up to this stage first lah. Okay, alright. Okay, the next thing okay, kita nak kira E0 cell. Okay, kita diberi overall equation. Okay, so again the same thing, you kena tahu siapa anode, siapa cathode, and the E0 cell punya value lah. Okay, alright, and N pun, bilangan elektron pun kita kena tahu. Okay, so daripada overall equation, apa yang you nampak? Okay, magnesium undergoes oxidation. Okay, so magnesium ni adalah kita punya anode lah, dan zinc undergoes reduction. Okay, which means zinc is our cathode. Okay, so kita kena, nak tak nak, kita kena tulis the half and overall equation untuk nak pastikan lah, okay, kita punya bilangan elektron tu semua betul. Okay, so magnesium undergoes oxidation at anode, release 2 electron, and at cathode zinc ion receives electron to form zinc metal. Okay, so now if you see the bilangan elektron tu dah balance lah, which is 2 lah. Okay, so our value of N you should know sama dengan 2. Okay, alright. And now to calculate the E0 cell. Okay, E0 cell is equals to E0 cathode minus E0 anode. Okay, so cathode adalah zinc lah. So again daripada table ni, okay, so mungkin kecil sikit lah tapi you boleh refer dalam you punya nota tu. Okay, alright, for zinc it's minus 0.76, and for magnesium kita punya anode adalah negative 2.37. Okay, negative 2.37. Okay, so now going back here. Okay, cathode adalah negative 0.76 dan anode negative 2.37. Okay, alright, so your E0 cell value tu you should get positive 1.61 volt lah. Okay, positive 1.61 volt. Okay, so now you dah ada value kita punya E0 cell tu. Okay, and you dah ada our N value which is 2 log K. Okay, So it's just maths lah. Okay, you kena find the K value tu, nanti kena shift the log tu semua. Okay, you should get your constant value tu as 2.465 times 10 to the power of 54. Okay, alright. Okay, so untuk B pun actually it's the same exact question. Okay, so again, okay, kita tentukan dulu siapa kita punya anode dan cathode lah. Okay, so if you see bromine ni, dia undergoes reduction from 0 to -1. Okay, so ini adalah kita punya cathode lah. Okay, kita punya cathode. Dan iodine ni, iodide ion from -1 to 0. Ini adalah kita punya anode. Okay, so you must be clear with this, siapa kita punya cathode, siapa kita punya anode. Alright, okay, so again the same thing lah. Okay, so again the same thing. First, make sure you are able to write the Nernst equation lah. Okay, so E cell equals to E not cell minus 0.0592 over N log concentration of ion in the product over concentration of ion in our reactant. Okay, alright. Tapi kita tak perlu any values je lah. Sebab apa? Dia dah bagi tahu suruh kira K. Maksudnya kira K tu at equilibrium lah. At equilibrium. Okay, apa yang you kena tahu, kita punya cell potential tu, E cell tu sama dengan 0. Dan ni concentration ion product over reactant ni, kita punya Q tu kita samakan dengan K. Okay, so we rewrite again. Okay, so nanti okay, kita tinggal E not cell sama dengan 0.0592 over N log K. Okay, and next okay, so we just want to make sure lah, okay, berapa kita punya N value tu. Okay, so we must do the half equation untuk anode dengan cathode lah. Okay, so anode apa yang kita tahu, iodide ion tu oxidize jadi iodine. Okay, so we add a 2 here in front, and then sebelah kiri negatif 2, sebelah kanan kosong. So kita letak dekat sebelah kanan 2 elektron. Okay, and at cathode what happens? Bromine gas undergoes reduction to give us bromide ion. Okay, so we balancekan bilangan dulu. Okay, and then we add 2 electron on the left lah. Okay, to balance the charge. Okay, so if you see kita punya electrons tu dah balance lah, which is 2 electrons. So our N value tu sama dengan 2. Alright, and then again the same thing. Next is to calculate the E naught cell tu. Okay, so E naught cell adalah E naught cathode minus E naught anode. Okay, so cathode adalah kita punya bromine dan anode adalah kita punya iodine lah. So looking back at the table okay, so looking back at the table, okay, ini adalah kita punya iodine lah, which is positive 0.53, and our bromine is positive 1.07. Okay, so cathode kita bromine positive 1.07, dan kita punya anode adalah iodine positive 0.53. Okay, just substitute the values. Okay, should give you 0.54 volt. Okay, so ini adalah value kita punya E naught cell lah. So we just substitute here. Okay, dan kita dah tentukan kita punya N value tu as 2. Alright, okay, log K. So solving this should give you the K value of 1.751 times 10 to the power of 18. Okay, Alright, so make sure you're clear okay, with the steps tu. Alright, okay, so this is another question. Okay, so dia cakap a galvanic cell ada zinc half cell lah. Okay, zinc ion dengan zinc half cell, dan kita ada SHE lah, standard hydrogen electrode tu. Okay, so the first thing this robot adalah calculate the standard cell potential. Okay, dia suruh kita calculate the standard cell potential. Okay, so you kena tahulah SHE ni dia punya E0 cell value adalah 0.00 volt lah, dan zinc E0 value dia adalah negative 0.76 volt. Okay, so apa yang kita perlu tahu dekat sini adalah, okay, so untuk zinc dia punya E0 value lebih negatif, so dia adalah kita punya anode, dan SHE kita adalah cathode. Okay, then baru you can proceed to calculate the E0 cell tu, which is E0 cathode minus E0 anode. Okay, so cathode kita is 0, our anode is negative 0.76. So this one should give you positive 0.76 volt lah. Okay, okay, next dia suruh kita calculate cell potential. Okay, kalau standard cell potential tu E0 cell, kalau cell potential tu E cell. So kita kena pakai Nernst equation lah. Alright, if the concentration of zinc ion is 0.45 molar, okay, partial pressure or pressure of hydrogen tu 280 m, dan concentration of kita punya hydrogen ion is 1.8 molar. Okay, so before we proceed lah, before kita proceed dengan Nernst equation kita, apa kita kena buat? Kita kena buat kita punya overall equation dulu. Okay, so kita tahu anode kita adalah zinc. Okay, so what happens? Zinc will be oxidized to give us zinc ion lah. Okay, ni zinc oxidized to give us zinc ion. Okay, so dia akan release 2 elektron. And at cathode, okay, untuk SHE okay, untuk SHE hydrogen, apa yang berlaku? Hydrogen ion tu akan reduce to become hydrogen gas. Okay, hydrogen ion will be reduced to become hydrogen gas. So we balancekan bilangan ni, and then we add 2 electrons lah on the left. Okay, so our equation is all balanced. Okay, equation kita balance in terms of number of electron lah. So 2 elektron So our n value tu you kena ingat nanti untuk part B, our n value is 2. Okay, so we just combine the equation ini. Zinc reacts with, okay, kita punya hydrogen ion will give us zinc ion and hydrogen gas. Okay, so now kita boleh proceed untuk nak kira kita punya E cell. E cell is equals to E0 cell minus 0.0592 over n log. Okay, so saya dah bagi tahu, okay, apa yang kita perlu include adalah in aqueous and gaseous state lah. Okay, macam yang kita belajar sebelum ni. Okay, tapi kita boleh tulis serentak lah. Okay, so maksudnya dekat produk kita dapat zinc ion aqueous dan kita ada hydrogen gas lah. Okay, so kita ada zinc ion, okay, dan kita ada hydrogen gas. Okay, kalau contohlah depan hydrogen gas tu ada 2, nanti dia akan jadi kuasa 2 lah, sama je. Okay, dan reactant kita hanya ambil yang aqueous ni lah, iaitu hydrogen ion Okay, dan kalau you perasan ada 2 mol depan tu, so dia akan jadi square. Okay, alright, now what we do, we proceed. Okay, masukkan values tu. E0 cell kita dah kira kat atas 0.76. Our n value tu is 2. log, okay, concentration of zinc ion ni is already given here, 1 molar. Okay, 1 molar. Partial pressure of hydrogen is 2 atm lah. Okay, 2 atm. Dan concentration of hydrogen ion kita adalah 1.8 molar. So jangan lupa square tu. Okay, and solving this should give you the cell potential value as positive 0.77 volt. Okay, so I hope students semua clear dengan working kehendak soalan, and then macam mana kita nak buat step by step to get us our cell potential, our E cell. Alright. Okay, so another question for second hour, the last question ni. Okay, so dia suruh kita predict lah whether the reaction ni can occur spontaneously or not at 25 degrees Celsius, given that Fe2 plus punya concentration is 0.6 molar and cadmium punya concentration is 0.01 molar. Okay, so you kena faham dekat sini, ini bukan under standard condition lah. Kalau standard condition, concentration dia 1 molar, okay, perlu 1 molar. So kita boleh terus kira E0 cell tu, cathode E0 anode, E0 cathode tolak E0 anode. Okay, dan kalau value dia positif, maksudnya dia tu spontaneous lah. Now our concentration is not 1 molar, maksudnya bukan under standard condition. Okay, bila bukan under standard condition, you kena faham kita kena kira E cell menggunakan Nernst equation. Okay, so how do we do that? Okay, so we do one by one lah. Okay, so what we can do first is write the equation first untuk kita punya anode dengan cathode, and then find out dia punya E0 value tu. Okay, so siapa yang undergoes oxidation? Kita punya cadmium. Okay, from cadmium solid to cadmium ion lah. Dan siapa yang undergo reduction adalah kita punya iron. Okay, alright, so cadmium will give us cadmium ion plus 2 electron, dan at cathode okay, kita punya iron tu, ion reduce jadi Fe, so you must add 2 electrons here. Alright. Okay, so now if you see kita punya electrons ni balance lah, which is 2 electron. So nanti our n value tu you must know is equals to 2 lah bila kita nak buat Nernst equation nanti. Okay, so whatever is on the left we write on the left, and on the right side of the equation tu kita tulis dekat sebelah kanan. Alright. Okay, so now what we do, okay, kita kena tentukan dululah kita punya E0 value tu, untuk cadmium berapa, untuk iron berapa lah. Okay, so kalau tengok balik sini, alright, so untuk cadmium untuk cadmium, where is cadmium? Okay, here is cadmium. Okay, the value is negative 0.40. Okay, for cadmium is negative 0.40, and for iron it's negative 0.44. Okay, alright, so for cadmium it's negative 0.40. Okay, and for iron the value is negative 0.44 volt. Okay, and then our n value tu is 2 lah. Okay, so what we calculate dulu sebelum buat Nernst equation tu, kita calculate dulu E0 cell kita, which is cathode minus anode. Okay, so our cathode is our iron, which is negative 0.44 volt, minus our anode, which is negative 0.40 volt. Okay, so it should give us as negative 0.04 volt. Okay, so now we dah ada all the information that we need. We calculate E cell. Okay, which is E naught cell minus 0.0592 over N. Okay, 0.0592 over N log. Okay, concentration of apa yang ada dekat produk, okay, aqueous ion lah, cadmium ion, over reactant kita aqueous ada iron ion lah. Okay, so E naught cell is minus 0.04. Our N value is 2. Concentration of cadmium is 0.01, and concentration of Fe2 plus is 0.6. Okay, so solving this should give you a value of positive 0.0126 volt. Okay, bila nak tentukan sama ada reaction tu spontaneous ke tak, okay, konsep dia sama saja. Okay, untuk E naught cell ke untuk E cell sama saja. If the value is more than 0, that means the reaction is spontaneous. Okay, so E cell tu greater than 0 lah. Okay, E cell tu is greater than 0. That means that the reaction is spontaneous. Okay. Alright guys.